Okay, our next speaker is here from Israel. That's awesome. That's definitely the farthest I think I've had anybody come forward. I can't think of anybody that came further for that. So round of applause for coming here for this. He's going to talk about cybersecurity automated with Kubernetes. Take it away. Thank you.
Let's see each pages. I just want to make sure that everybody can hear me without the mic. Is all good? Okay, awesome. So first of all, thank you for OWASP San Francisco for having me. It's really awesome actually being here and meeting the community. So thank you for being an attendee and also for the host. I'll be talking today about cybersecurity in general and the matter of risks against companies and how we actually automated that whole process of auditing and doing things in the world of cybersecurity research with Kubernetes and the whole infrastructure of Google Cloud. Because we're in a cybersecurity meetup, we have to have hoodies and a guy actually trying to hack something, and once we have that off the table, we can continue on with the talk. Some important things about the talk. What I'm not, a Docker and Kubernetes expert. What you won't be after this talk is also Docker and Kubernetes experts. But what you will be is basically happier people because I've stopped talking. And you also will know our problems, how to actually solve them in the matter of technology. And you will know how to search things and where to search things about Docker, Kubernetes, Google Cloud, maybe some security. And because Grant kind of told us the meaning of life.
Keep it away.
Yeah. Okay, so a bit about myself. I'm the co-founder and VP R&D of Tenrace. We're a startup company. I'm also a Google developer expert, which basically means that Google certifies me that I talk a lot. So if you don't stop me, and actually ask questions, I'll just continue on. And I'm also the co-founder of several development communities. One called Big Things. It's focused on big data, data science, and DevOps. The other is GDG Cloud. Surprise, it's focused on cloud. And also an alumni association of my unit in the Israeli Air Force. So in the past, I was in the Israeli Air Force for 8 years. And there I developed a missile defense system. And afterwards, I worked at a big data company called Windward. Basically what I did with missiles in the military, I did with ships when I retired. And currently, again, I'm the VP R&D of Tenrace. So, because we're talking about security, what is cyber? Can anybody tell me? Okay, you see a lot of fails here that we talk about cybersecurity in general. But basically security is talking about technology, having a lot of action upon it, and also having processes in place. They're really like annoying things that we don't like to do in a matter of forms, and a lot of processes that companies introduce to make life harder for developers and also for security people. This is also important in the world of cybersecurity. I gotta ask, how many people are software engineers? Okay, and how many are security people? DevOps? Ops? Awesome. Okay, so in general, you're feeling my pain, I think. And the pain of all of the companies basically having vulnerabilities always come up. And why? Because we don't write code, we write bugs. Okay? And vulnerabilities are security bugs. You won't be surprised about that. Okay, so when we look at the landscape of how we look at a company, we need to take into account a lot of different layers, okay? Eventually what we're trying to protect in every company or like even ourselves as human beings are assets, files, identity, talking about anonymity, pseudo-anonymity, content, and all the data realm of privacy in general. Afterwards, we're creating another circle, right? We need some kind of mechanisms to protect ourselves with, right? So we're talking about encryption, about Tor, anonymous services, something about two-factor authentication, encrypted communication also, firewalls. These are all means to actually have us being more protected against cybersecurity threats. So let's talk about the threats. Phishing. phishing, all of sorts of kinds of phishing that we have, spying, malwares, things that we're creating as security people to actually know how to hack better, or also things that we have in a matter of mass surveillance, adware, exploit kits, things that are developed from the outside also. But who is trying to do all of these things? The adversary, right? So we need to talk about spies, hackers, crackers, but we can speak about other malicious entities in our companies, our ex-partners, okay? Disgruntled employees. Everything can actually happen, and even like 15-year-olds who can download and install Kali Linux and just brute force all of our infrastructure. Pretty easy, right? Okay, so eventually, when we talk about all of these like terms, basically we have risk. This is vulnerabilities, threats, and consequences afterwards. So what do we do in Panorama? A nice sentence, but basically what we do is help our customers to manage the cybersecurity risk that is imposed by their suppliers. Okay, today the world has kind of changed because like 20 years ago, CISOs would actually talk about like their own safe silo, everything is protected in their own data center, but today we don't hold any of our data. Okay, how many of you are using cloud? Okay, and it's gone. All of your data is there. Okay, and because of that, you need to take into account that a lot of cloud service providers, marketing tools, even CRMs, ERPs, all the interconnected applications. Or for example, you can also talk about like our law firm and accounting companies. We send out all of our contracts and most confidential data via emails, right? What's happening in the world of cybersecurity on their side? Nobody actually knows. Okay, a lot of times nobody cares, but yeah. So eventually we look at every company and in general the supply chain management in the hacker's point of view. Okay, and we're continuously scanning all of the suppliers and companies of our customers 24/7, giving 360 overview on all of our infrastructure. And of course we do that installation free. We collect all of the data from open source intelligence, look at the perimeter of the company, also like threat intelligence, etc. So this is what we do as a company. But we had a problem. And in general, what's the hardest problem in software engineering? Just tell me. Okay, now you this. What?
Naming convention.
Damn. Yeah. Okay. 7 points to Tad. Naming things. Okay, this is one of the most annoying things that we have as software developers. We waste a lot of time on that. Okay, I won't say waste, invest a lot of time, right? And because this is like a tech talk, I have to take something scientific from Quora. Literally, this is the answer of most engineers that say that naming things is hard, okay? Because we need the intent for that. So, we need simple steps for the solution. We appointed the CNO, Chief Managing Officer. He's the go-to guy for all the hardest problems, actually. Right now, let's not do it. We need to actually define the problems and abstractions that we've had in the company. So basically, parallelism used to happen in the matter of companies. So we used to launch a VM per company, per customer. Scans and evaluation process wasn't that transparent. And the server utilization was low because we're doing a lot of scanning, we're querying a lot of APIs, we're going network traffic, right? And because we're doing outbound and inbound network, we're not blocked by CPU. So usually I'm ramping up new servers without any utilization of the CPU and just wasting money, okay? And of course, it's hard to build an internal orchestration framework, okay? How many of you have tried to do something in the world of big data distributed systems and building an orchestration framework? Okay, how fun was that? It's a blast. A blast, okay. He's like, we did that with the Cron and Dash, actually launching servers, etc. And it wasn't that fun, I must say. Of course, we need to monitor all that, and we need to control everything via a simple API, right? So, eventually, like every startup, we start off with the biggest question of either building a monolith or like being like all of the cool kids and building microservices, okay? So eventually, like every startup makes its decisions, but everybody ends up with a microlith, okay? This is an important term because you eventually start off with migrating your monolith to microservices, but eventually you end up in a situation in which you can deploy your microservices simultaneously. Okay, so everything should be deployed together. We didn't do anything. So in the beginning, we started off with Demi mesh. After that, we've had a virtual server. Lots of virtual servers. And everything used to run sequentially, job after job, because we're doing scanning, right? So we're doing the discovery phase. We're afterwards understanding the tech stack, correlated assets of the company, etc., and creating a risk model on top of it. So for that, we've created the transporter. It's a dynamic workflow engine that actually runs on top of Kubernetes. How many of you know Flask? Okay, so it's a combination between Flask and Celery, okay, which is a distributed queue. And this in general is a tech stack. We have the web API that is accessing the transporter as a web service, and we're launching all of the tasks or jobs on top of Kubernetes, and afterwards creating a dashboard for the CISO to actually review all of the results. And everything should be transparent and efficient, parallel, and of course automated, without any need of human intervention. How many of you know Kubernetes? Awesome. Who's that? And so I'll talk a bit about that also. Kubernetes is a framework that came out of Google. Okay, it is based on top of Borg, which is their own internal Docker and container orchestration in general. It is fully open source, and it is based on all of the best practices basically of orchestrating big data workloads also. It's fully written in Go, and it manages applications and not machines. This is the important notion to keep in mind. How many of you are vegetarian or like vegan? Wow, I'm really sorry about that. In the past, we used to take into account our servers as pets, right? Everybody had their own names. They were unique and rare. Okay, I would install them and do like all of the, take care of them. They needed personal attention. Okay, if something went wrong, I need to go and pet him, of course, and maybe change some parts. And if it gets ill, you make it better, of course. We kind of changed that notion, okay? And when we started to talk about, in general, containers and orchestration, etc., everything is cattle. Everybody has numbers, okay? One is much like the other. They run as a group because I manage fleets, and if it gets ill, you actually make hamburgers out of it. So this is, again, the offending part, sorry. But a lot of times when people talk about Kubernetes, they talk about different kind of terms. And always in the demos, you will see like long-running services, blue-green deployments, all the cool things that all the cool kids are using. Deployment services, replica sets, pods, labels, and all of the query language on top of Kubernetes, etc. But nobody is actually talking about batch operations, about jobs. Okay? And we've used that intensively now. How many of you have seen the movie Transport? Yes, okay. A really cool movie that means literally nothing. Okay? A lot of explosions, a lot of people dying, but basically it has a basic set of rules that we've kind of based our own workflow engine on top of. The deal is a deal. No names, never open the package, and never make promise that you can't keep. Okay, the deal is the deal. Basically, we've created some kind of workflow and dismantled it into smaller pieces of jobs, phases, and workflows that are running on top of the infrastructure. And things can run in parallel and sequentially. And of course, this is the whole reconnaissance lifecycle of a hacker. And basically, we mimic that also. Never make a promise that you can't keep. You need your infrastructure to be reliable. Okay, and the most important thing are retries, scheduled jobs that I want to have. And of course, kind of like identify the timeouts and do something about it. Almost never make a promise that you can keep. What happens if something fails? You need notifications, you need monitoring, and you need, of course, to have transparency on all of your infrastructure. And no names. This is something that actually happened to us because security engineers in general are over-descriptive people, okay, and they like to show what they're doing. We kind of got to the limitation of naming conventions in Kubernetes, okay? It's up to 63 characters. And because they used to like run their jobs and call them by their name specifically, things started failing, and we didn't understand why. again, because you run a job over 63 characters, bam, it explodes, and you don't understand why you think there is a bug, etc. So we kind of changed that method of mapping out the names of the services that I'm running, because we're running hundreds of different kind of services, to hashes that are mapped out to that, and then we have an identification system that actually sees which are the jobs that are running. So what do we have on our cluster? The transporter service itself. Long living services, APIs that we can actually call and start on workflows. Workers as deployments. Basically, the workers are taking the tasks from the queue and initiating them on Kubernetes. Redis servers to keep some kind of persistency and for it to be super fast. And Kubernetes jobs that are triggered by the transporter on a different cluster. This is the most important thing. Why? We kind of got to another limitation of Kubernetes and running on Google Cloud specifically. We killed our own network. Because we were doing a lot of traffic and the intermediate traffic between Kubernetes and things, basically we started having some timeouts in the matter of TCP also. So it was a pain in the ass, so we understood that we need to kind of like distribute that in another way and launch all of the things on a different Kubernetes cluster. What's next? Workflows, monitoring. What's next was actually like the whole roadmap ahead for all of our infrastructure. And we've implemented a lot of these things. Basically, this whole process began like a year and a half ago. So we added more and more functionality, and we're adding more and more functionality as we go. Oh, sorry. And workflows, monitoring. We created Grafana. How many of you know Grafana, by the way? An awesome tool, I must say, an awesome open source based on Kibana also. And we've created Grafana and dashboards to have as much transparency as possible about APIs that we're using, workflows that are running on Kubernetes, and also on all of our internal infrastructure, correlating information from the low-level infrastructure and the business logic that is running on top of it. So basically, if I have a lot of companies that are running, logically I can understand that the peaks in CPU and network traffic is because of that. And also having configs maps as versions. We kind of tied that in our CI/CD process to have labeling like with the deployments themselves according to the Git versions that we have. So all of that automation is also occurring, and also asset level parallelization that will come in the future. Okay. Conclusions. From my experience, I think more than 12 years with developing distributed systems, if you can possibly not do a distributed system, don't do so. Take a beefy server, run everything on multiple CPUs with a lot of threads, awesome. If you don't have that possibility and you want that flexibility, then basically you will need to address the pains and kind of develop your own infrastructure, or at least use some kind of service to leverage that. And Kubernetes is a great container orchestration tool. How do I know that? Basically because Docker, the company that had developed the format itself, had kind of adopted Kubernetes as the running engine to their own orchestration framework that is called Swarm. Okay, and all of the leading cloud service providers are developing some kind of infrastructure as a service or managed Kubernetes service. And you can actually install that on bare metal also. It is not that much fun, but it's getting much easier with a different kind of like orchestration installation frameworks. You can use Puppet, Chef, Ansible, all of the other cool things in the market today to actually install that with playbooks. And one more important thing is perfect is the enemy of working and giving value. Because if we had waited to implement all of the possible features of the transporter, basically it would have never gotten to production. I'm 100% sure about that. So the initial process began of migrating some of the services and not running everything on Kubernetes. It was running partially some of the workflow on regular VMs and then migrating part for part. This is the most important thing to take in mind, because then we understood all the problems that occurred during the process itself. If I had deployed something as a bulk, usually I can't even compare what was in the past and what's new. And one of the most things that I actually am most proud of is that all of our security researchers are also developing production code in scale. Okay, and this is not something too common, because a lot of times security engineers are super talented people which know how to get to the pinpointed location that they want. If it's recovering the I don't know, records from the database or getting the exploit done, but what happens when you need to do that 10x, 100x, 1000x? Then it's a pain point. And usually what they do is hand off the ability or something to engineering. And this actually takes them out of the loop of what customers are getting and what people are using. And we tend not to do that. And because of that, we've created some kind of like infrastructure for them to be able to do a CI/CD process and create their own code and deploy that with the transporter in Kubernetes. And this is something that is really good in my opinion, even if it takes like 200% of the time. It is good because they're connected to the production environment. Okay, after I spoke really, really fast, probably your faces are like this, and I'm really up for any question. Yes?
You said you migrated to Kubernetes slowly. What were you using before that? How long did it take you to migrate?
Okay, so the question was, we migrated slowly to Kubernetes. What were we using in the past and how much time did it take us? We were using in the past regular VMs. Everything was deployed on a single VM. This was the deliverable. A lot of Python scripts that ran sequentially. Okay, and everything was deployed with an image. So basically even closing that image as a deployable used to take an hour and a half. It's a real pain. So eventually what we started doing is created the infrastructure to actually run and execute all of the jobs. And after we had that ability, we started migrating part of that process that used to run sequentially and run distributedly on Kubernetes. So instead of launching a whole full-fledged VM, we used to run a part of the process in the VM, and then afterwards migrate the part or the relevant part of the scan to Kubernetes. So this whole process of actually like creating the infrastructure took about, I don't know, 2 or 3 months. Afterwards, because again, we did that partially. And afterwards, we've deployed more and more services. So that whole time span, I think, took around like 8 or 9 months. And eventually we got the system.
Services did you migrate?
What?
How many things did you have to migrate?
90-something services, I think. Because they were running like 90-something versions of code, different kind of code. But eventually you have like hundreds of different jobs that are being ran. And that's about it. It took like around a year to migrate fully from the old version. And you always need to compare like what's going on right now when I deploy the new service according to the old version that we have. That's it. Yes?
What started to break to have you guys use Kubernetes?
Again, sorry.
What factors, what things broke essentially to have you move towards?
Okay, what broke to make us to move to Kubernetes? First of all, we didn't have any transparency on what's running. Okay, this was one of the biggest pain points. So what happens? Okay, for example, if you have like 10 customers, all is good. Okay, what happens when you have hundreds and thousands? Then basically even the failures, even if it's like 2%, you can actually see that. You don't have transparency on that. And of course, eventually you end up with money. Okay. And running all of these servers eventually will get to thousands of dollars easy. So when you're utilizing your Kubernetes cluster and trying to run Docker containers, it's much more efficient, of course. It really depends on the use case, because if you're like doing 100% CPU 100% of the time, then basically no Kubernetes and nothing will help you, because you have a specific amount of CPUs to run upon. But what happens when you have a lot of like network traffic, right? Outbound, asynchronous things. Then basically you are not utilizing anything. Yes, again.
I think I just have most of the Kubernetes questions. Are you guys using like the auto scaling of the cluster feature?
Yeah.
How long does it take to scale, do you know?
Think of it that Google does that for me. So spinning up new nodes are super easy.
But how long does it take?
In a matter of seconds. But again, it really depends on how many servers you need to launch, because you have a quota, a specific quota as a cloud user. So if you're planning to scale up and down really fast, okay, then you need to define yourself a really large quota. But think of it that we are super predictable, because I know how many customers I have, I know what kind of subscription they have, and I know how to utilize my cluster. So usually I live up like around 30% of all of like extra exponential growth that usually won't happen. And if I onboarded a new customer, which I do that like manually because of the salespeople are doing that, then I just add more servers. Okay? I don't need to use that functionality much. But Google does that well, really.
Well, I'm using AWS plus Kubernetes and I'm trying to like load test.
EKS?
I'm sorry.
You're using EKS?
So I'm just using, deploying Kubernetes on AWS.
Fun facts.
Right. It's new, like you just have the clusters up, and I'm trying to figure out like, how do we load and test this in a way where we know it'll be able to scale fast enough.
You should use fleets, first of all. Fleets. Server groups that are being launched differently, okay? And then having them being introduced to new clusters. Because a fleet might launch faster than actually autoscale. You should try that. Again, I haven't used AWS for the last 3 years. A lot has changed, but you should try that. Okay? I really hope it helps. Awesome. Okay, how much time do I have? Okay, there's 5 more minutes. If you have any other questions, come to me afterwards. If not, thank you very much.